All right. Thanks, Ron. Okay, so I'm going to talk about generative AI in finance. Generative AI has been a buzzword since last year after ChatGPT came out. I'm going to explain, in general, what generative AI is and what technologies are available at Microsoft for generative AI, and what type of use cases are being implemented in the financial services. So, brief history. Artificial intelligence is nothing new. It's as old as 1956. I believe it or not. The idea was to create machines that can imitate human behavior, that can think like human and process information like human. So, machine learning is a subset of artificial intelligence, which can do pattern recognition and prediction. And then deep learning is further subset of machine learning, where it's mostly a neural network that could be used to do some of the AI functionality like vision and text analytics. So generative AI is like further subset of deep learning. So basically, there was a specific language model called transformer, and to making that language model bigger and bigger, eventually we were able to get to a point where it imitates more human like behavior than ever before. So that large language model that is used to generate things like, from images to text to documents, that's why it's called a generative AI. Now, these are some of the key milestones that Microsoft has had. 2016, we achieved a human parity in object recognition. 2017, human parity in speech recognition, and the list goes on. Finally, 2021 is for question answering. That's when Gen AI is what enabled us to achieve that. Right? This is the overall Microsoft AI portfolio. Right at the top, you see the SaaS applications. These are your M365 and Dynamics 365 and partner solutions that you might be using. And most of these have AI embedded, right? So Microsoft 365 now has the Microsoft Copilot. Dynamics 365 has the Sales Copilot. So, Copilot and some of the automation is done through AI. So, these are SaaS applications that just have AI embedded in them. Then you have, plumbing applications, which are like, no code, low code platforms to stitch together stuff to build your AI application. These are things like Power BI, Power Automate, Power Virtual Agent. This is the whole Power platform that can be used to build AI solution using no code, low code. Right? Then you have pre-built models. Some of these are like deep learning models, like document intelligence, cognitive search, which is now called the Azure AI search. These are pre-built, pre-trained models that are primarily using deep learning models that are still very good for some use cases. Then you have some of the customizable models. So you have your vision model in cognitive services, but these models also allow you further customization, that you can provide it more images and labels to recognize images that it's not being trained on. Right. So some of the cognitive services models, they allow you for further customization by applying, giving it more data. And then Azure OpenAI service kind of falls within that, and Azure OpenAI service is the generative AI offering from Microsoft. And right at the bottom, you have the Azure machine learning platform, which is, if you want to build a model from scratch, that's when you would use Azure machine learning, because it has very low level things, like it allows you to write your own code from scratch. Okay. So for generative AI, the main thing that makes generative AI work is the large language model. And these large language models, if you think of compute like a calculator, so these large language models, they take text as a user input. Then they use things like, looking up things related to, like if you're asking, will my sleeping bag work a trip to Patagonia next month? So like there are several angles to it, right? So, you're asking question about me. So there is personalization involved. There is, weather involved. So depending on how the weather is, that determines, whether that bag would work. And then there is recommendation. If that doesn't work, what else is there that you could do, right? So on top of that, there is different intent, what are the actions that you might take, and context, like, the location, those are some of the context that's provided, right? So all of these is part of what we call prompt engineering. So prompt engineering is how you structure your input to get the exact output that you want, and all of this needs to be fed into a large language model, and then the large language model would give you the response, right? But that's in general how large language models work, and these are pre-trained large language models. And having those pre-trained models means that you can only ask it whatever it knows, and you can make it connect to internet, like the Bing chat for enterprise, right? So it you connect it to Bing, and then it has access to all the internet data, so it can access more latest information and give you more up-to-date information. But for most organizations, the use case is, th- I want to know, based on the data that I have, I want to ask questions on my data, not the all the data that it's already trained on, or whatever public data is available on the internet, right? So for that, you need to augment the already trained large language model with your own data. And the technique that's used to do that is called retrieval augmented generation. So the typical flow is you would use an orchestrator which would call something like the Azure AI search, which would index all of your data sources, and then it would also connect to a large language model. So the orchestrator, given a user input, it would first call the AI search to get information about all the data that you have that has been indexed by AI search. And once that data is available, all of those data will be added as context into the prompt. So, the prompt would get embedded with your own data extract through AI search. And then that prompt will be sent to the large language model to get answers that are very specific to your data. Right? Now, one of the technique that's used to index all of your data is called embedding. So embedding is a way to convert a chunk of text into a, like, ones and zeros, a numerical code that can be used for search. So once you have embedding, which is like an array of numbers, so now you're able to represent your text as a number. So then that number can be used to do things like cosine similarity search across all of the other text that you have that have already been embedded, to create a numeric array for that. So using embedded, you can now search across all of your data points, and that's how you get the relevant data. If the augmenting data is not enough for you, the next option is for fine tuning. Now, be aware that for 99% of the use cases where you need to ask questions on your data, RAG pattern is your go-to solution. It's also more cost effective, it's more configurable, uh, it's easy to adapt. That's going to give you what you're looking for majority of the time. There are times when you want more faster response, right? Because the RAG, they work by embedding the text that you find from your internal data search. So because it's embedding your prompt with additional context, the prompt size can be larger and the processing can be slower, and you can sometimes speed it up by fine tuning. In the fine tuning process, you take a large language model which is trained on a large data set, then you provide it a new data, create a new deployment, not a new model, but a new deployment that now has all of this new data already indexed in memory. Because of that, you no longer need to pass the information from the new data as a context within your prompt, because it already has that. Because now you're passing less information in your prompt, the prompt processing and the response is going to be much faster than it is with RAG pattern. But again, be aware, this is a more expensive option, and it is only for that 1% scenario. So you have to really evaluate your return on investment before you go the fine tuning route, because majority of times RAG pattern is going to be good enough, and there are now talks of RAG 2.0 where all of the components can be custom built. So that's a better way to go than thinking about fine tuning. For a more advanced large language model implementation, people who need to really customize things at code level, these are some of the popular libraries that are used. There is Semantic Kernel, which is a Microsoft library for orchestrating large language model and a code. The biggest benefit of semantic kernel is that it has both C Sharp SDK as well as Python SDK. So if you have .NET apps and you are trying to add Gen AI features to it, then semantic kernel is your obvious choice. LangChain is another open source Python library, but it's a Python. So if you have a Java or .NET, then you have to kind of interface it with Python through REST API or something like that. But LangChain is very popular. It's an ever growing package. There are lots of new features getting added all the time. Then there is AutoGen. If you need to build an agent type application, that your Gen AI has some agent that has some reward mechanism to perform a particular task, that AutoGen can be used to build those agent-based application. Then there is Core Interpreter, which is another library that can be used primarily for generating Python code and understanding Python code. Typical use cases in Gen AI, majority of use cases are around summarization. So, you have a large document. So, give me the key insight. So, if you use Microsoft Teams, there is a feature called notes in a meeting, right? So, you can enable Copilot in Teams. So, as the meeting happens, it will start taking the note. And in case you miss the meeting, you could just see the note and you kind of get an idea of what happened in the meeting instead of having to go through the entire recording, right? Then there is a data-driven decision. So once all those data is indexed, so based on that RAG pattern, you can ask questions based on the data that you have. Uh, and further use cases, now there is personalization. So now that you have the data and your preferences, you can have your Gen AI application personalized to a specific type of user, a specific persona. Okay. Then there is automation. So any repetitive task, you can have your Gen AI application perform through agents and plugins. There are different technology available for creating automation, like somebody booked a travel, could generate a report, submit the expense budgets, things like that. So, what are the options available in Azure to build Gen AI application? There is, from left to right, it's low code to code, right? So you have your Microsoft Copilot, which comes with M365. That's your no code solution. So there are some level of customization that you can do to Microsoft Copilot, but you cannot write code to, you know, add low level logic to it. It works the way it works. You cannot retrain it. You cannot even, fine tune it, or there are ways to it kind of by default works in a RAG manner, so you don't need to set up your RAG pattern. Once you deploy Microsoft Copilot, it has access to everything that is available in your Dataverse or your Microsoft Graph, and it can answer questions on your organization using that Microsoft Graph. Then if you need some level of customization, for example, in Copilot, you want to add a plugin, right? Those type of work you can do using Microsoft Copilot Studio. Again, it's still a low code platform that allows you to write some code, but it's a very drag and drop UI driven IDE that can be used to customize your Copilot, typically adding plugins to it. Then you have Azure AI Studio, which is a fully developer mode. You can write your custom code, things like semantic kernel, LangChain, you name it. You can use AI Studio with there is something called prompt flow, which can, it's similar to semantic kernel, but it's more UI based. So you can drag and drop LLM and Python code and stitch together stuff. You can write as much code as you need to. It helps you in terms of setting your parameter in a GUI way. So it's kind of semi GUI and semi code. But using AI Studio, you can make your Copilot development a lot easier. But it's a very low level code. You can really customize anything. You can add data sources to create your RAG pattern. You can fine tune. You can add your custom logic and your agents to make it do what you want to do. So this is kind of the layers that you have. So right at the top with Microsoft Copilot, you have your apps, and you can extend your apps using plugins. Okay, so that's all you can do using your Microsoft Copilot Studio, right? Then for things like using prompt flow to do model evaluation, using meta prompts to kind of personalize your Copilot, grounding it to your organization data, plugin execution, selecting a particular type of LLM as a foundational model, selecting your infrastructure. All of these can be done using AI Studio. Along with that, there is something called responsible AI that AI Studio uses for to build in safety into your development process. I will talk about more about responsible AI later. Okay. I did a separate talk just on LLM ops. If you are interested, it's available on Angelbeat YouTube channel. You can look at it. But the process of developing an Gen AI application, it goes through these loops. So you have your business need that's defined. You create a project. You build your Gen AI prompts, and build the application. Then you prepare it for deployment. You get feedback to see whether it meets your business metric, and then you go back to rebuilding. This is kind of the operational chain of LLM, what we call LLM ops, as like DevOps. Okay. Now coming to the final use cases for financial services. uh, we talked about broad use cases for Gen AI. Now specifically for financial services, summarization again is the most frequently used case. You get a document, you get a summarization of what is the document about and what are the action plans. Those are the most frequent use cases for Gen AI. Then there is generating content, like generating a deck, creating a financial investment portfolio proposal for a customer, uh, generating insurance claim documentation, uh, or creating a credit card offer, right? Things like that. For recommendation, that is using the customer data. You can create a recommended, for example, for a credit card scenario, you can create a collection strategy based on a customer's payment history. You can create a a proposal for private investment based on the portfolio that the customer has, right? You can also simplify tasks like automation that we talked about, right? You can prioritize emails. Based on emails, you can invoke actions within your CRM platform or whatever else you connect it to. Now, finally, coming to responsible AI for financial services organization, since it's heavily regulated, uh, there are audits that happen, and you need to be ready to let your GenAI application be audited to prove that it's safe, that you don't have biases. For that, a responsible AI framework is built into most of the Microsoft AI development platforms. You get, for example, in Azure AI Studio, you get some of the meta prompt and best practices prompt. You get safety features built into those prompt, so that things like jailbreaking or prompt injection attacks can be prevented. Once a model is built and you want to operationalize it, you want to evaluate it against against particular metrics like groundedness, relevance, fluency, coherence. And Azure AI Studio has functionality to do all of these evaluations once you have your AI model deployed. Finally, when your application is running, you want to continuously monitor it, and you want to be able to add another safety layer on the output. So for that, there is a content filter feature available in AI Studio. So you can say things like, violence, hate, or, sexual harms, things like that. You can set your threshold, and based on that, AI Studio is going to create a custom filter that will be applied so that your outputs are filtered according to the thresholds that you have set. Okay. With that, that's the end of it. If there are any questions, I can take it, or can leave it to the end.